Okay, so what you're looking at here is a treadmill board replacement. Okay, with components that you can buy from Amazon or Wish for about $20 or so, and it consists of three three parts: a AC control module, a bridge rectifier, and a DC motor control. Okay, and then we have our treadmill motor that's 90 volts DC in North America. Treadmill motor, 2.5 horsepower, 13 amps at full load amps. Okay, so we have 110 volts in. This is different than in Australia or in Europe, where they have 220 volts in. Then you can probably get away with just AC control and a rectifier and bypass this DC control, because this is already DC and you can adjust that over here because their motors are 180 volts DC. Okay, so anyway, so this is for North America, and it's different, a little bit more complicated because we get more amps going out to the motor. Okay, so this is what I'm proposing. You saw my videos already where I attempted to repair the board, the original board in a treadmill. And then I tried to just using a DC motor control, using the DC coming out from the main board, but that was at 160 volts DC, and that's too much for the board that you can readily buy for cheap for about $10. Okay, so this is what I'm doing. Okay, so I'm gonna have a motor control AC in. The parts are coming. I will show you the video when it comes, unpacking the components, putting it together, and testing it out. By the way, the DC control did work, but only for up to a minute. Same thing when I tried it with the DC, just AC control and the DC rectifier, bridge rectifier. So it worked for a while. I could actually adjust the speed, and then it just went full speed because the triac inside the module shorted out, so it's always full speed. So you're putting in 160 volts on a 90 volt DC motor, which is probably even faster than it's supposed to be running. And by the way, I'm not interested in full speed. I'm just interested in lower speeds on the treadmill, just for casual walking, because my wife has issue walking, so she just wants to be able to walk on a belt without doing extreme running or anything like that, just walking. Okay, so keep that in mind. I'm not interested in, I could run at full speed as well. And then also, before I forget, what I want to add to this is a kill switch. Okay, so that's gonna be the switch that was that is in the treadmill, that usually has a clip attached to it that you attach to yourself, and this is magnetic. So if this is removed, this opens up. Okay, so that's what I'll be adding on after. I just want to explain this because it's sort of complicated, but it's not. When I actually show you how it's done, it's going to be clearer than just looking at schematics. Okay. So in a nutshell, we have two modules and a DC rectifier. Okay. So basically we get 110 volts in, You got to make sure we size this control to be able to handle up to 20 amps, or that's what it comes in. You don't need that much. Okay, so this control I will adjust to about 64 volts AC out, and then I'll get 64 AC coming into the bridge rectifier. What I'll get out in DC is about 90 volts DC. Then I'll leave this control at this setting. So I'll have a 90 volts DC. Then on the motor control DC board, which can control up to 40 amps, 90 volts DC. So then I have DC in and DC out. I can adjust from 0 to 90 volts. So my speed is going to be adjustable from 0 to 4,000 RPM, which is the original or the treadmill motor, 4,000 RPM. Okay, so that's in a nutshell. So also there's another component that I added here, which is a electrolytic capacitor rated at 220 or whatever. That's what I got here, 200 volts DC. So I'll put that on the output of the DC. So coming out from the rectifier, going into the DC motor control. So I'll have a capacitor there to filter out, because if it's too choppy, if the voltage coming in is like so, then you're gonna have a kind of choppy, noisy motor running. Okay, so we want to put in a capacitor so that we filter out this here, so that it's more or less straight voltage without so many dips. So that's going to make the motor run more proper, quiet. Okay, so that's in a nutshell. And this here, I'm thinking I'm going to incorporate this switch, these close contacts when everything is okay, when the clip is on. In this circuit here, I'll have to test it in either side, either this one or that one. I think this side, that's plus on a board, that's usually 0 to 5 volts DC control. So by adjusting this 0 to 5 volts DC, that adjusts the output from 0 to 90 volts DC, and in this case 0 to 4,000 RPM. Okay, so I'll probably incorporate that in here. So this is going to be my switch, this one here that has the string attached to it. So when it's pulled, it opens up, and I get 0 volts in. But I'll have to test that, make sure that it actually works that way, or even putting it in series with this, because that will cut out the volts coming in. So probably in here, that should be the safest. Then I get 0 volts in. But yeah, I'll test that when we assemble it, and we'll go from there. All right, so for now, that's all there is to it. This explanation is a little bit much theory, but I just wanted to get this out as I'm waiting for parts.